Hello, geometry, and welcome to lesson 5 of topic 1. We're going to talk here about conditional statements. So, conditional statements, um, basically, as we go through this class, you're going to encounter a lot of theorems, and a lot of our theorems are written as conditional statements. So, it's important to introduce you to what a conditional statement is. Okay. So a conditional statement is simply an if-then statement. It relates a hypothesis, the part that follows if, to a conclusion, the part that follows then. Okay, so again, a lot of stuff in there. A conditional comes in the form if-then. It relates a hypothesis, which follows the if, and a conclusion that follows the then. All right, so again, down here, if, and then the next words are the hypothesis. Then, and the next phrase is the conclusion. And again, if you think of like a scientific experiment, right? The hypothesis comes first, the conclusion is typically the end of the experiment. So we use notation. P and Q are typically our hypothesis conclusion letters. The arrow means if then. So again, this P arrow Q is read as if P then Q. All right, so again, a lot of like background basic stuff right now. So again, we're just learning here. So it says write the statement as a conditional. So again, when it says conditional, it means write it as an if-then statement. So it says you can register to vote if you are at least 18 years old. So this word if kind of gives us a starting point. So instead of putting if in the middle, we're going to put if first. If. And then this phrase right here, this is going to just be our hypothesis. HYP, hypothesis. It's going to follow the words if. If you are at least 18 years old, then, and now here comes the conclusion, and this part is going to be our conclusion, then you can register to vote. And there we go. Hypothesis, conclusion. Again, it was weird though that the conclusion was given first and the hypothesis was given second, but again, that keyword if helped us out. Okay, next, a square must have 4 congruent sides. So there is no if in this problem, so we're going to go in order here. So the first idea, the hypothesis, is about being a square, right? This is the hypothesis idea. The second idea is about having congruent sides. This is going to be your conclusion. So we need to make this into an if-then form ourselves. So we're going to say if, and the generic idea of a square is a polygon. If a polygon is a square. And instead of using the word polygon, you could also have used the word quadrilateral. So quadrilateral is a 4-sided figure, a 4-sided polygon. So if a polygon is a square, then it must have 4 congruent sides. And there we go. If then form, being a square as the hypothesis, having 4 congruent sides as the conclusion. There we go. All right, next. Okay, so now we're going to talk about what are truth tables. So find a truth value of a conditional. So the truth value of a statement is either true or false, right? So it can't be maybe. It's either true or it's either false. What we do is we have what are called truth tables. Truth tables are just generic tables that represent all possible combinations of truth values for 2 or more statements. So if you look at this truth table, this is the truth table for our conditional if P then Q. So you have the hypothesis, which is P. You have the conclusion, which is Q. So for P and Q, there are two options, true, false, for the hypothesis P. There are two options, true, false, for the hypothesis Q. 2 times 2 is 4. This is why there are 4 rows. So typically what we do is we let the first row represent true, true, then false, false. So the first statement being true twice, the first statement being false twice. Then we alternate the second one, true, false, true, false. This gives us all combinations. So true, 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 false, false, true, false, false. All possible combinations of those two statements. All right. So now in this truth table, the only time a conditional is going to be false is if it has a true hypothesis and a false conclusion. This is the only kind of different one in the bunch. Because if you tell me the hypothesis is true, but the conditional turns out to be not true, then that conditional is not going to be true. It's almost like you set me up for failure. All right. So be aware of this. Okay, so how can we determine the truth value for the conditional? If a number is even, then it is divisible by 2. So we can have even numbers. So we're going to say that this hypothesis is true. You can have even numbers. So now the question is, are even numbers divisible by 2? Is the conclusion also true? Well, yes, the conclusion is true. So we are doing true, imply, or if true, then true. That would be this first row. And when the hypothesis is true and the conclusion is true, then the conditional is true. This is a true statement. And I think we knew that, right? An even number is divisible by 2. Okay, if a quadrilateral has two pairs of congruent angles, then it is a parallelogram. All right, so let's assume that this hypothesis is true, because we can have a quadrilateral with two pairs of congruent angles. So for instance, so let's keep reading. So then it is a parallelogram. Okay, so the question is, does a quadrilateral with two pairs of congruent angles have to be a parallelogram? Well, let's draw some out. So here is the parallelogram, right? That does. Squares have 4 right angles. Rectangles have 4 right angles. A rhombus also has opposite sides congruent like this. But what about what's called an isosceles trapezoid? Now again, I think they expect you to know a little bit more than you might know already. This is an isosceles trapezoid. We'll talk more about this as we go through the year. I think topic 6 talks about quadrilaterals. But in isosceles trapezoids, the two angles on the top base are congruent and the two angles on the bottom case are congruent. But this is not a parallelogram. So this is where the conclusion is false. So our true hypotheses led us to a false conclusion. This is the only time that your statement is going to be false. And again, this kind of goes back to the idea of counterexamples, right? Were we able to find a counterexample where the hypothesis wasn't exactly true? And there we go. I'm sorry, where we had found a counterexample where the conclusion wasn't true. And there we go. Okay, so we're going to stop there. We're going to get more into different conditional statements and more about truth tables in the second video.